Hello, this is Britt Caswell with another example video. In this video, I'll be covering example 1 from section 4-3 in the SavvasRealize Algebra 1 textbook. So in this example, we are looking at the third way to solve a system of equations, which is a method that they're calling adding. Most places call this the elimination method. So I'm going to write that here at the top, elimination, which is where we are eliminating a variable. So here we are, we have a system of equations. I'm going to mark this one as the blue one, and this one is the red one. And so with the system of equations, what we're looking for in order to be able to use the elimination method, or the adding method, if that's what you want to call it, is you're looking for this situation right here. So do you see how our y values have the same coefficient, right? They both have an imaginary 1 written in front of them. And then they also have opposite signs. One is positive and one is negative. So what that means is that I could take these two equations and I can add them together, right? So x plus 2x is 3x. But watch what happens when I go to add the y's. I add y plus negative y, and they cancel each other out. It eliminates the variable. That's what's happening there. And then here, 7 plus 2 is 9. So by adding those two equations together, I have gotten rid of the y variable, and now I have a single equation that just has one unknown variable. So I can divide by 3, and I can get that x is equal to 3. And of course, now that I know what x is, I can go back to either equation, and I can use that x value to solve for y. So I'm actually going to go back to the blue equation, this first equation, just because it has fewer coefficients. So where the x is, I'm substituting in the 3. So then to get the y alone, or to isolate y, I'm subtracting 3 from each side. So I get that y is equal to 4. Now remember, your final solution has to be written in an ordered pair. So make sure that you're using those parentheses and that you write it, as our usual ordered pair. So I'm going to write solution here. Let's go ahead and let's try another one. So here on 1a, our y's have the same coefficient. They both have a 4 in front of them. And one is a negative 4 and one is a positive 4. So I can go ahead and add these two equations together, and these y's should eliminate each other. So 2x plus negative 2x is just x. Negative 4y plus 4y, those cancel. And then 2 plus 3 is 5. So we automatically get that x is 5 here. So then we can pick one of the two equations. I'm just going to pick the top one. And where the x is, I'm going to replace it with the 5 that we just got. So 2 times 5, that's 10. And I'm going to subtract that 10 from both sides of the equal sign, because we're trying to get the y by itself. So here, 2 minus 10 is negative 8. And if I divide by that negative 4, I get that y is equal to 2. So my final solution is going to be the ordered pair 5, 2. Alright, let's go ahead and let's try it one more time. So on this one, we have 2's in front of the x's, and one is positive and one's negative. So I'm going to add the two equations together. So 2x plus negative 2x, those cancel out. 3y plus 2y is 5y. And then 1 plus negative 6 is negative 5. So if I divide both sides of the equation by 5, I get y is equal to negative 1. And then again, it doesn't matter which equation I go to, but I can plug into one of these equations. Again, I'm going to do the top one just because it has fewer negative numbers in it. I think that's a little less intimidating, right? And remember, when you substitute this y into the equation, make sure that you're using parentheses. Otherwise, you'll look like you're saying 3 minus 1, which isn't true. So here, 3 times negative 1 is negative 3. And so to get the x by itself, I'm going to have to get rid of this subtraction first. So I'm adding 3 to both sides. So I have 2x is equal to 4. And then I divide by 2, and I get that x is equal to 2. So my final solution is the ordered pair 2, negative 1. So there you have it. That is how you add two equations to eliminate a variable. Until next time.